Hello YouTube, thought we'd do another video here. This is going to be part 4 of the squelch or slash busy line on the interface circuit that I'm building so you can hook up your Midland MXR10 or the Retevis RT97S to your computer. Those repeaters got a data port on the side. This is the busy slash squelch circuit that I'm working on. The good news is we don't need to use a hex inverter. We can use a transistor. So I do have hex inverters on the way. I ordered some, but I was able to use a transistor to do this, which I'm trying to make the circuit so that when you order parts, you can get like, in this case, I got 2 transistors I use. So now when you order them, you know at this point in the video, you would order 2 transistors. These resistors. I'm trying to keep it so that I'm trying to keep everything the same so you can get 5 of one thing or 2 of one thing, if that makes any sense. So I'm trying to keep it simple as possible. Okay. So like I said, I'm using a transistor. I will show you my little circuit build up close after I demonstrate how it works before I unhook everything. Now, I have a USB DB9 adapter that's plugged in my computer. The computer's off camera. You cannot see that. This meter here is what you're seeing on your display, which is right here. Okay, this meter here will indicate when the software, this repeater software, is in transmit mode. So when you see a voltage here, 5 volts or higher, that means it's in transmit mode. Down here, you will see right now it's waiting for a signal. It's waiting for reception. It's waiting for a signal to come in. When it's activated, you'll see recording down here. Okay? Now, let me clear this, get my pen out here. So, this meter, like I was saying, is what you see on your display up above the repeater software. I'm using this free repeater software that has many functions, but that's what I'm using to test this, to get it so we can build this interface circuit. So now you're going to also, for the squelch or busy line, you're going to need a wall wart. You're going to need a 5 volt. If you can find yourself a wall wart like this, 5 volt DC output, because this squelch circuit is going to need power. Unfortunately, there's no way around that. Not a big deal. You can get a wall wart pretty cheap. I like to make note that the pin we're talking about here is what they refer to a busy. Okay, it's an active low when it's activated. This is the Midland pinout schematic, which is the same as the Retevis RT97S repeater. They're the same repeater. So when I say squelch, because that's how I think of the circuit, is a squelch, I mean busy. It's the same thing. I just want to be clear about that so I don't confuse people. Squelch, busy, COR, they're all the same term. But it's got to be an active low. When the repeater is activated, when it receives a signal, whether you're talking the Midland MXR10 repeater or the Retevis RT97S repeater, those repeaters have a data port on them. But when one of those repeaters receives a signal, that pin 3 of that connector goes low, almost 0 volts. When the repeater's waiting to receive a signal, it is high, of 5 volts, actually 4.95 to be exact. The good news is I have a gentleman in my Zello channel that has the Retevis RT97S model that has the data port, and he measured with a meter what is it when it's in the high state, when the repeater's waiting for a signal. It's 4.95. What is it when it's receiving a signal? What is active? How low does it go? And he checked it with his meter. It's actually a minus 0.011. So, which is perfect. So this circuit should work really good. Okay? I had someone confirm it with their meter on my Zello channel. So I feel real good about that. So, and if you want to, just to make it clear, I guess, this is the Midland pinout. I'll show you the Retevis. It's the same. They're the same repeater, guys. They're the same repeater. I don't care who tells you, try to tell you differently. They're the same repeater. Same thing. This is the Retevis pinout, pin 3, busy, which means squelch. Same thing. So when I say squelch, I mean busy. They're the same thing. I just want to be clear about that. They should just use squelch, but whatever. So anyway, so that's what this is. So when the repeater's waiting for a signal, it's 5 volt on that pin 3. Pin 3 will measure about 4.95. When the signal comes in the repeater, it goes to low. So what I did here, I don't obviously have those repeaters here. So I have to trick the circuit, which is the same way it would act as if I had the repeater here. Okay? So I have 5 volts tied to pin 3 right now to represent the repeater is waiting to receive a signal. So as soon as I make that pin go low, if everything's working, you will see here says recording signal or recording, I think it says down here, and you'll see more than 5 volts up here. And like I said, up here it tells you that it turns on the transmitter, and down here it's telling you it's receiving the signal. Okay? Now obviously I don't have any sound hooked up. That's another part. We're just doing the transmit, the squelch / busy, and we did the PTT already. I did a video on that. So that's what we're doing today, is the squelch. So when I do this, you'll see recording down here, and it should be more than 5 volts up here when I make that pin be low, just like it would be in the repeater when it's receiving a signal. So by doing that, if I unhook this jumper right here, it's gonna make that pin go low, and there we have it. It's low, it's recording in progress, it's receiving the signal, and it's transmitting if I had it hooked up. This voltage here tells me it would activate the transmitter of those repeaters, and it's recording this. It's recording the incoming signal, or the incoming signal is being detected. Okay, so that's what it's telling me there. So this circuit's working great. Now if I put that, let's say the person's done talking, blah 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 blah, and they get done, boom. Goes back to waiting for signal, and after a couple, I think there's a delay you can adjust it in the software, and this should unkey, and there it goes, unkeyed it. So again, watch down here, it's going to say recording, and the voltage goes here. Person keys up the repeater, they're talking to their buddy, blah 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 blah, boom, I keyed up the repeater. We're recording in progress, and we got an output of 5 volts that's activating the PTT of that repeater. Whether it's the Midland or Retevis, it doesn't matter. They're talking, hello, how you doing, da 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 da. Now we're done talking, we're going to unkey the radio. And now we go back to waiting for signal, and after a few seconds, it will unkey the repeater here shortly. So this circuit is working exactly the way it should be. Which is good news. We're on a good roll now. Now I want to explain a little bit about this circuit so that you kind of have an understanding. It's when you build this, try to keep everything. Of course, in this video I'm using jumpers because I have to. But when you build this circuit, I'll show you the circuit up close here after I'm done with all this, and I'm done with the demonstration now. But I'll show you the circuit up close. Try to keep all your leads short, because when you're dealing with a transistor that's got to act like a switch, we're using another transistor to act like a switch. And what I did here is I have you can't see it, it's off camera. I have a 5 volt wall wart hooked up to this squelch circuit. That's how I'm getting my 5 volts to supply, so that the circuit has power to do the 5 volts. So I have that off camera. You can't see. These leads right here are the power coming in. This is ground. This is positive. And then to trick the circuit to put a high on pin 3, I just run a jumper over to the pin 3, and that's how I'm able to trick it. When I remove this jumper, it acts like it's a low. It's going to activate the circuit as you just saw. Okay, so how a transistor works is that it needs 0.6 volts or lower to turn on. So if I was to, if you had this, you build this circuit, you want it hooked up as close as to the repeater you can. I mean, if you put the repeater in a different room and you run, a cable from your repeater to this circuit, you may have problems because it could pick up noise in the wires. So when you do this, keep this circuit as small as possible to avoid any noise pickup. And what's going to happen is, if that is to happen and it picks up noise, it could increase that voltage and make it not the squelch circuit work. Remember, it needs 0.6 or lower. So anything above 0.6, the circuit's going to think it's a high and it will not work. So try to keep things, pretty tight when you build the circuit. And then don't run your little circuit through a cable plugged into the repeater. Like I said, don't put the repeater in another room and then you run a DB9 cable all the way, across the room to the circuit. Don't do that. Try to keep it close, so you can plug it directly into the repeater and keep it close to the repeater to avoid the circuit picking up any interference. So I want to make that clear. So now what I'm going to do is I'm going to unhook this. I'm going to show you up close this circuit. And like I said, I will do a schematic once I get all this done. I don't want to do it now and then I find an error. So I'm doing it a little bit at a time. We still have to do the audio part. And that's going to be the next part of the video, is going to be the audio. We have to get audio off the repeater into the computer. So that's going to be another part. But so far, the good news is we got this busy line working. We got the PTT line working. We got everything working good. So, yeah. And like I said, this circuit here, when you see 5 volts, that's my test point. Actually, in the circuit itself for the PTT, it grounds it like it's supposed to. But for testing purposes, for demonstration, I have it show you 5 volts on the screen here. I just want to be clear about that. And I did a video on the PTT, so you can watch that video. So let's go ahead and show you this circuit up close. Let me turn all this off here. Bear with me. I'm going to unhook everything. We'll put this underneath the microscope here. We're going to turn everything off. And for making this video, I'll show you what I mean. I have test points that are soldered onto the circuit, which you won't be doing because you don't need to do that. So, but I had to do that to hook up my leads here. So I got test points. And let me unplug. I'm going to unplug this. So there's that. And I unplugged it. And I made it so that I could plug this in. If I had a repeater here, I could plug this right into the repeater and plug my cable in. I used 2 female ends on here, my little adapter thing that I made. I think I already showed you that before. But so let's go ahead and move some of this stuff. Let's call up the microscope here. And we're going to show you this up close, or at least try to here. Okay. Now, this right here, this transistor here is the one that does the PTT. This is the one I just added for the squelch. Okay. Now, let me get this better in frame here. Okay. So, I have another diode in there. It's kind of like for spike. Resistor. And then it's tied to ground. And this lead right here that goes to this the busy squelch transistor, I don't know if you can see this. I clip on my wall wart to it. That's the 5 volts from the wall wart go to this resistor. Okay? Now these pins, this part would go to the repeater. This is the repeater side. So be mindful. There is a repeater side and there's a computer side on this plug. This is the computer. This is the repeater side. This is the repeater side. This is the computer side. Because remember, these connectors, these connections just don't go over. Pin 5 on here does not go to pin 5 on here. So that's why there is a computer side and a repeater side. This is the repeater side. So that's what this test point is right here. This is where I put my 5 volts from the wall wart. And then underneath it here, this test port here, this little test wire, that's what's hooked up for the meter you saw on the display. You wouldn't obviously be soldering that on there, but that's why that's there, just to explain why that's there. And I have female ends on both, so this could plug right into a repeater, no problem. So that's how I have this. Like I said, this is just for my 5 volts from my wall wart to supply power to this transistor. Not this one, just this one. This is the busy squelch transistor. This is the PTT transistor. Okay? So, and then this is the ground, and that's how I got that. But I'll do a schematic on that much better once I get everything hooked up. The next part, let's go back to the other camera. The next thing that we got to work on is we got to work on the audio part of this. We got sound that comes off the repeater. We got to feed that sound into the sound card on the computer. If you look at the schematic, like I mentioned before, the good news is Midland schematic kind of gives you some values here. For 60% audio level, it's 30 millivolts. And we can use that that scope. I did a video on that USB sound scope for $8. You can hook to your computer. I did a video on that. You can use that to try to adjust this or figure out the adjustments. But we're going to have to add. We got to do the microphone and the speaker out. We're going to need it next, coming off the repeater. But we're going to have to add a variable resistor in here because I got a feeling we're going to need to adjust the volume coming off of that. And as you know, or maybe you don't know, these repeaters, the Midland MXR10 and the Retevis RT97S, do not have volume adjustments, which is not normally a bad thing, but when you're interfacing this to a computer, the volume coming out of these pins might be too high. Yes, you can do some adjustments on the computer, but you still might have to do some adjustments on here. So we're going to have to add a variable resistor, and I got to figure out what value we're going to need to do this. So at least it kind of give me, let's clear this. At least it kind of give me some numbers to go by. Like I said, 30 millivolts for 60 watt or 60 modulation or 60 sound level, and then 250 milliwatts into a 32 ohm load or a speaker. So I have some, numbers to try to figure out what values we're going to need. So, but that's going to be the other part of this series. So, but right now we got the squelch or the busy, and we got the PTT working. So we got those working just like they should. So good news, we're making progress. Okay, so now we're making progress, so that's good news. I'd like to thank Pete for checking that too in my Zello channel. I appreciate you getting your meter out there, Pete, and checking those voltages on the Retevis RT97S repeater. I think that's about it. I think we pretty much got this covered. If you have any questions or comments, please post them down below. Please subscribe, and thank you, and have a good day.